Good morning, students. Today we are going to learn about chapter number 11, three-dimensional geometry. Three-dimensional geometry carried 9 marks. Three-dimensional geometry se mark mapan lai ko. Three-dimensional geometry da yam important oriba topic sing se direction, cosines and direction ratios of a line. Nangi directed line amagi direction cosines na kaino, direction ratios na kaino habis yam important way ko. Nangi line ama tamba matamda. Then first we define direction cosines. Direction cosines yana define torusiko. Let alpha, beta, and gamma be the angles made by a directed line segment OP. Nangi line se directed direction yawgadaba ko aduga origin phaw oigadaba. Let alpha, beta, gamma, BA be the angles made by this directed line OP with x-axis, y-axis, and z-axis in anti-clockwise direction respectively. Nangi alpha, beta, gamma se nangi OP have a line siga x-axis, y-axis, z-axis ka make the angle hoitaragadi then cos alpha, cos beta, and cos gamma are called the direction cosines of the line. Direction cosines of the line ko we call. Hausen hagi buse kaino alpha beta gamma sina nangi given directed line segment amaga x-axis, y-axis, z-axis ka make the angle oitaragadi cos alpha, cos beta, cos gamma gi value do kai korani direction cosines of the line koreko. And also direction cosines can also be defined as kamana define the way I haradi nangi directed line segment OP ama laireko. And let us consider this E can be a unit vector acting along kanada ek tawba OP vectors the ek tawba unit vector name khalaseba. The components of any unit vector denoted by E cap acting along a given directed line are called the direction cosines of the line. Nangon the line directed line semen ampiradi unit vector amputhokpadi yani unit vector haivadi kaino a vector of magnitude 1 haivaniko. The components of any unit vector acting along a given directed line segments are called direction cosines haivadi. Direction cosines se ways ani the defined where in terms of angle the defined amana in terms of component they express the where and the direction cosines of a line are generally denoted by kaina denote we L, M, N, small letter L, M sina always denote we ko direction cosine saitaragadi L, M, N na direction ratio saragana ABC oigadaba adu mathangda koina direction ratio sigi definition se define tawrase. Now we are going to define the direction ratios of a line. The components of any vector which is parallel to a direction cosine vector E cap are called the direction ratios of the line. Nangon de any vector ama huziki vector se kanada parallel oigadaba direction cosine vectors sabidi E cap haiba ma direction cosines lowriba vector ama di laini dana adugi vector sida parallel oiba any vector samagi components sing se direction ratios ka oiba ko. Direction ratios saitardi kaino the components of any vector which is parallel to E cap are called direction ratios of the line. Parallel oiba means nangi E cap ki components sing sida any scalar amna multiply taraga phangbo oiba adugumba component amagi components sing do vector amagi ko adu kai korani direction ratios ka ko. Next, relation between direction cosines and direction ratios of a line. See important ni ko. Nangi line amagi direction cosines ka direction ratios ka gi marakta lainaba relation haiba. Sida direction cosines na karamba no direction ratios na karamba no fazana khangasi ko. Kona first is the line ama ye OP haiba directed line ama ye ko. Let E cap and the E vector E cap haiba maga E vector haiba maga vector ani laure. E cap sina unit cap ni E vector sina any vector ni ko acting along this line OP sida ek to hole E cap B any two vectors acting along the directed line OP the ek to ko then sigi E cap sa kanagi unit vector ne na khanba ya then we can assume that this E cap is a unit vector acting along E vector the ek tawbane na khanba yai ko habidi moibani si chapmana na ngasai gi OP haiba directed line segment si the ek tawba vector ani oirabani na and therefore this E cap can be expressed as E vector divided by magnitude of E nangi E vector da magi magnitude na divide tawbane na khanba yai duna direction cosine saitar di L M N ni ko direction ratios ti ABC na denote hole sida e cap ki component iro li cap plus mj cap plus nk cap. Then write this e vector ai cap bj cap ck cap divided by find the magnitude of e vector. E vector gidi root over a square plus b square plus c square, where a, b, c are the components of this e vector. E vector sigi component ngaktani ko. Do this sigi se khona corresponding component naam se equate ours by equating the corresponding components of the vector left hand side and right hand side. Compare to bukande L is equal to a divided by root over a square plus b square c square period. M is given by b divided by root over a square plus b square c square. N is given by c divided by root over a square plus b square and c square. X ne x ka y na y ga z ka component mana duine baduna relation between direction cosines and direction ratios of a line height are the kaina pirani. E cap is given by E vector divided by magnitude of E have. Sigi E cap siga E vector siga parallel tagadava. Parallel means they are acting along the same line segment. Line segment amada chamana ne ek tawone na khalaga. Sigi E cap sa E vector damagi magnitude of E sina divide tawagi concept laktuini ko. E cap haragadi direction cosine set krani E vector haragana direction ratios. Any vector amagi component sing sina direction ratios kawi aduga E cap ki component sing duna direction cosine side duni ko ani sigi relation khangani. Direction cosines na kaino direction ratios na kaino haigani ko. Next, we are going to learn about relation between the direction cosines of a line. Direction cosines sigi marakta lainariba relation sing. Let E cap be a unit vector acting along a directed line OP, and let alpha, beta, gamma be the angles made by this line OP with x-axis, y-axis, and z-axis respectively. Koina diagram ami ko. OX, OY, OZ, right? Three coordinate axes intersecting at the point O. Here O is called origin. Then draw OP line segment OP starting from 0 to P. And P the chatle ko. Duga sida E cap haibam khaloba. E cap is a unit vector acting along this directed line segment OP whose components are L I cap plus M J cap plus N K cap. Let alpha, beta, gamma be the angles made by this OP with x-axis, y-axis, and z-axis respectively. So when the condition means and we know that I cap, j cap, and the k cap are the unit vectors acting along x-axis, y-axis, and z-axis respectively. Si mamang dalo hay grabo nga tani ko I cap na x da, j cap na y da, duga k cap na z-axis da ek tawe. Adudi hause koina puthok tu se kena relation between the direction cosines of the line haibaneba. Direction cosines sing sigi marakta karamba relation lay haibaduni ko. Sigi E cap siga I cap siga ki marakta lebe angle se alpha nena logbi E cap siga J cap ka gina beta laire ko. E cap siga sigi z axis ka gi marak sina gamma natra. Adudi koina scalar product ki rule sijinaraga si cos alpha se puthok pe angle between any two vectors ki concept puthok se ko. First find the scalar product of I cap and E cap. I cap dot E cap will be equal to magnitude of I cap magnitude of E cap multiplied by cos alpha, where alpha is the angle between I cap and this E cap. Ani sigi marakta lebe angle duni ko. I dot E cap, I dot, then write the components of E cap, Li cap plus Mj cap plus Nk cap is equal to magnitude 1 multiplied by cos alpha. Unit vectors ngatani. Do this scalar product law was say. First find the scalar product of this I cap with first term, second term, and the third term ne. First term khatang exist ni, but first term se kai ta ni L fangani ko. I dot I will be equal to 1, and here their scalar is L fange ko, and I dot J will be equal to 0, and I dot K cap will be equal to 0 since I dot J ga I dot K ga maram se 0 chatleba. Maram hangtar di kai gino I is perpendicular to J cap and the I cap is perpendicular to K cap. Perpendicular wherebanina cos 90 ki value se 0 chale ko. And so this cos alpha is equal to L. Nang cos alpha ki value se kya ka manare L ga manare ko. Similarly, we can show that cos beta is equal to m, cos gamma is equal to n. The L, M, N sina in terms of component da pivani, alpha, beta, gamma sina angles da pivani ko. Aduga nangi cos alpha gi value ga L ga manare, cos beta gi value ga m ga manare, cos gamma gi value ga n ga manare ko. Asima khangani. But E cap is a unit vector, so whose magnitude will be equal to 1. Sigi magnitude se 1 tabam to eva. Aduna root over. Find the magnitude of E cap in terms of component. It will be root over L square plus M square plus N square is equal to 1 tareko. Again, squaring on both sides, we have L square plus M square plus N square is equal to 1, and also cos square alpha plus cos square beta plus cos square gamma will be equal to kya tabam to 1 tabam to ko. Maram kaigino hai taragadi ngasai E cap ki magnitude sina 1 tarakpanina modulus lauraga koina L square plus M square plus N square have a relation che 1 ga manhale. Siniko, this is the relation between the direction cosines of the line in terms of component. This is the relation between the direction cosines of the line in terms of angle. Sina angle the piva, sina component the piva. Nangi direction cosines oigi hai taragadi nangi number ahom dogi square tauraga sum puthokpase kya tagadaba 1 tani ko. Next topic, direction cosines of a line passing through two given points. Given point ani faraga chatpa line amagi direction cosines putho haibuko. The first akoina point ani khalase. Let us consider any 2 points, point A whose coordinates are x1, y1, z1, and point B whose coordinates are x2, y2, and z2. Sumainta raga koina point ani laureko. Point ani laure in space ta lebe any point ani nina khale. Hausik tawduise kaina, we are going to find the direction cosines of the line passing through these 2 points. Koina anka holi se vector danga tani ko adudi vector ani se point ani se join tawraga vector ama form tawbadi yani AB vector haibam form tawbani OA join tawre. OA means position vector of the point A. OB vector means position vector of the point B niko. Then the direction cosines of the line passing through A and B is the unit vector acting along AB vector. AB vector have A ga B ga join tawragana vector am phangise mangon the ek tawraga leba unit vector am oireba, that is AB cap se oidoini ko. Now find AB vector. AB vector se putho. AB vector di OB vector minus OA, position vector of terminal minus position vector of initial niko. Then write the components of OB. OB ki components है x2ik plus y2jk plus z2kk. Then write the components of OA. x1ik plus y1jk plus z1kk. Subtract those. Find the difference of these two vectors, and then sigi vector and is subtract of they find the difference of corresponding components of x2 minus x1 I cap, x1 I cap, y2 minus y1 j cap, and z2 minus z1 k cap. Do the then AB cap putho. AB cap is given by AB vector divided by magnitude of AB ko. AB vector sigi component is x2 minus x1 ik plus y2 minus y1 jk plus z2 minus z1 kk divided by magnitude of AB vector is equal to x component square, y component square, and z component square ithoe ko. Chumaina iraba matungda sigi x component, y component, z component sida makhagi denominator sigi expression china divide tawdoi, and hence the direction cosines of the line passing through point A and the point B are x2 minus x1 divided by r, y2 minus y1 by r, z2 minus z1 by r, where r represents root over x2 minus x1 whole square, y2 minus y1 whole square plus z2 minus z1 whole square. Sumain tawraga koina puthokaneba. Nangna point ani phawraga chatpa line amagi direction cosines putho hai taragadi hanbada point ani the phawraga chatpa vector ama irani. Vector do iraba matungda unit cap unit vector among puthokaneba ko. Unit vector dugi components singduna direction cosines oigani. Vector dugi components sunduna direction ratios of the line passing through the given 2 points. Any vector amagi components in a direction ratios. Any unit vector amagi components in a direction cosines ko. chide yare ko which is the relation which is the direction cosines of a line passing through kana pharaga chatpa 2 points. Next exercise 11.1. Next, we are going to solve exercise 11.1, question number 1. Here the question is, if a line makes angles 90 degree, 135 degree, 45 degree with x-axis, y-axis and z-axis respectively, find its direction cosines. Nangi line nama pire, line sina 90 degree, 135 degree, 45 degree se x-axis, y-axis, z-axis ka same ko. Adoi taragadi find the direction cosines of the line. Direction cosines ki line puthok tare. Housing man in terms of angle the pire ko. Let alpha beta gamma be the angles made by the line with x-axis, y-axis and the z-axis. Sumain taraga kun ire ko. Adu di alpha na 90 tarani, beta na 135, gamma na kya tarani 45 tare ko. Then find cos alpha. Cos alpha is equal to cos 90 degree. 0 tagre ko. Then find cos beta. Cos beta is cos of 135 degree. This 135 degree can be expressed as pi by 2 plus 45. 90 plus kaida thambe must have 45. Cos pi by 2 plus 45 is changed into minus sin 45 to change the record. Minus la is a kaigino haradi 135 degrees se second quadrant. Second quadrant the cos ki value se negative taiko. Duna minus sin 45 tare minus sin 45. Value of sin 45 is equal to 1 by root 2. Sumain tore irekwa. Then find cos gamma. Cos gamma puthok se cos 45. Value of gamma is equal to 45 degree is 1 by root 2 tarekwa. And therefore the direction cosines of the line are given by kaina pigi cos alpha, cos beta and cos gamma na pidra. Here cos alpha is 0, cos beta is equal to minus 1 by root 2 and cos gamma is equal to 1 divided by root 2. Nangi given line dogi direction cosines se cos alpha, cos beta, cos gamma ki value na p ni. Sima hirani ko. Next question, question number 12. Si question se am toy hangi ko. Find the direction cosines of a line whose max equals angles with the coordinate axis. Nangi line sina x-axis, y-axis and z-axis ka make to be angle se chap manaba. Alpha beta gamma se chap manaba major angle amaga manaragadi direction cosines of the line se kana kaya oiduino habaduni ko. Let alpha, beta and gamma be the angles made by the line with x-axis, y-axis and z-axis respectively. Koina axis ahum ye ko x-axis, y-axis and z-axis o x, o y, o z, o p haiba koina line ama ye directed line ni ko amagi direction lay aduga sigi alpha, beta, gamma laura. Alpha, beta, gamma be the angles made by this directed line OP with x-axis, y-axis and z-axis. Then alpha equals to beta equals to gamma chap manani ba maramdi kaigino question da line duga axis ahum duga same ba angle si chap mane herame ko alpha beta gamma equals to alpha equals to beta equals to gamma equal ore. Then we have asagi relation between direction cosines of a line da koina kai phangi result ani phangi ko cos square alpha plus cos square beta plus cos square gamma kya gamma nagi 1 tadra. If alpha, beta, gamma are equal, then replace this beta and gamma by alpha. And we have cos square alpha plus cos square alpha plus cos square alpha. Cos square alpha is equal to 1 tareko. And 3 times of cos square alpha is equal to 1. And cos square alpha is 1 by 3. Which implies that cos alpha is plus minus 1 by root 3. Squaring lower. Taking square root on both sides of the equation. Square root low reko. The cos alpha की value से plus minus 1 by root 3 tare equals to cos beta and cos gamma. Alpha beta gamma chap manabani na koina kaidorani cos alpha na plus minus 1 by root 3 tabada cos beta su cos gamma su ani se loin taro si value se tarani plus 1 by root 3 oibay minus 1 by root 3 oibay ko. Hence, the required direction cosines of the line are kana ore plus minus 1 by root 3, plus minus 1 by root 3, and plus minus 1 by root 3. These are the coordinates of a line making equal angles with the three coordinate axes. Coordinate axis tuga nangi given line tuga same angle singje chap manaragadi magi direction cosine se plus minus 1 by root 3 plus minus 1 by root 3 and plus minus 1 by root 3 tareko. Next question number 3. If a line has the direction ratios minus 18 plus 12 and minus 4, then what are its direction cosines? Nangi line amagi direction ratios piradi direction cosines putho haibako. Koina mamangda direction cosines na kaino direction ratios na kaino haibisi tamgre ko. Direction cosines haibisina any unit vector ramagi component oiba. Direction ratios haibisina any vector ramagi component oiba. Nangonda direction ratios pi taragadi let the components of E vector will be minus 18ik plus 12jk minus 4kk. Direction ratios of the vector oina lauriniko. Then find E cap. E cap is given by E vector divided by magnitude of E. Then write the components of E vector minus 18ik plus 12jk minus 4k cap divided by root over magnitude low minus 18 whole square is 324. 12 square is equal to 144 minus 4 square is equal to 16. See sum puto. Find the sum of these three numbers 484. Since 484 is the square of 22. 22 is square ni ko. Do the square root lower the kya fange 22 fange. Then divide this term and this term by the denominator 22. Minus 18ik by 22, 12jk by 22 and a minus 4kk by 22. Dividing both sides by 2 na divide tawre minus 9 by 11 ik, 6jk by 11 minus 2kk by 11. And these are the components of E cap. E cap means a unit vector acting along this line E vector. E vector is the ek tawba unit vector ramo oiradra. The unit vector ramagi component fang taragadi kay ore. These are the direction cosines of the line niko. Direction cosines of the line orani. Hence the direction cosines of the line are minus 9 by 11, 6 by 11 and minus 2 by 11. Nangon is the direction cosines piramagadi. E cap haraga sumai itorakani wako aduga direction ratios harambagi kuina kay irino E vector. For today, let's end here.